Hello everyone. Today we are going to talk about social networks and all the data that is generated by them every minute. This data can contain a lot of interesting and useful information and can be used for a lot of applications. For example, we can understand market trends. We can see how people feel about a specific topic. We can identify key influencers in a niche. We can spot different communities inside the social network, or even we can handle crises with it, with this information. So in this video, we are going to show how we can collect information from Instagram accounts. That's the social network that we chose for this video. We are going to open it in a browser and show how we can extract this information from the developer tools in Chrome. And then we are going to format this information in a way that can be imported to a software called Gephi. Gephi is an open source software that is used to visualize graphs, and social networks can be represented as graphs with all the interconnection between the accounts, all the relationship, followers, followings, comments, likes, and all these interconnection can be represented as graphs. So we are going to visualize the information that's extracted from it and try to identify communities inside these accounts that were chosen. We are going to collect information from the largest first 100 accounts, and that's the idea for this video today. So I came into this site, Social Blade, and it lists the largest accounts on Instagram. And as you can see, the first ones have soccer players, have singers and celebrities, have brands, channels. So my idea here is to get different niches, different communities, and see if we can recognize them through the software. So I got these accounts, and then I started to get the information from them. Account on Instagram, and as you can see, they have a lot of followers. So what I did for the purpose of this video was to extract the followings of the account. And I believe that only with the followings we can already understand the interconnection between the largest 100 accounts, and we will be able to do the recognition of the communities. Okay, so to extract the information, we need to do the following. We can come here and more tools and developer tools. So we are come here in network and update this. As you can see, it populates a lot of requests. And if you come here and search for query, it will show you some JSON set response. This is the headers. By the way, if you want to get how the request is done, you can just come here, click right on your mouse and copy the curl command. So you know how to send this information if you want to make a program to do that. But I did it manually. And here is the JSON file with all the information of the account. Okay, so here you can just copy all like this and copy and do it for the 100 accounts. And then if you want to get the following, you have to come here. Let me remove here just to show how it goes. And it will start to populate all the accounts here, all the requests. So you have to go here down the list until it ends. Okay, it's the end now. And then all you have to do is come here and save the followings. And this is our a HAR file, and it's a JSON file. So if you come here and open it, here it is. If you open on Notepad, you can see that the record of all the requests and answers that we did during the navigation on Instagram. So all the information that you need is here. So what I did is I made a Python script that can extract information from both files that I showed to you for all the accounts. So with this, we have the information that we need already in the format that we will need to import to Gephi. So after extracting all the information from the JSON files, we will have a comma separated file with the following information: the ID of the account that will represent, that will identify uniquely the account on the Gephi software. Then we have the handle of the account and the name of the account. So this will represent the nodes of the graph, and the format that is needed for the nodes are this: source and target. So the IDs that are here uh, are linking the accounts like this. So we have 67,000 lines here on nodes, and accounts on edges, and on nodes we have about 48,000 accounts that we collect the information. So this is the Gephi software, and what we need to do is come here and create a new project. Okay, so let's import the information that we collected. So I use this because I did some cleaning on the data. So as you can see, there is the ID, the label, and the handle of the account. And here this part is important. I don't think this is a problem. Maybe it's an account that have an empty field, but this will not impact in anything. And here is, we need to be direct the graph type, because it's one account following the other, so there is a direction. And this doesn't matter because the edges don't have weights, and append to the existing workspace. So here are our nodes, and let's import the edges now. Okay, now we have the nodes and we have the edges here. Let's run some statistics. This software have a lot of statistics here, and let's run average degree. So it gave a 1.39 average degree. And let's run network diameter. It's running. It may take some seconds. And yeah, here's the progress. This will measure how many nodes we need to go through from one end to the other end of our graph. And the diameter is 6, so 6 nodes to from one side to the other side of our graph. Um, and this part that's very interesting is modularity. It tries to identify the communities. So let's run it. I increase here a bit because otherwise it will be a lot of communities. So I want to not have too many. So for the purpose of this video, will be enough if we use like 3, for example. So as you can see, with this resolution, we found 7 communities, and I will show you in a minute what does it mean. So here you see that we imported this part here, the label, the ID, and the handle. Uh, Now we have the in degree. That means that from the 100 accounts, 22 of these 100 accounts are following the Instagram account. 28 is following Cristiano Ronaldo here. We can order by here, so we know what's the influencer that is more influent on the 100 best largest accounts on Instagram. So you can see Beyonce is followed by 37 of the 100 accounts that we are searching here. Justin Bieber, 36, Rihanna. So what we can do here is try to come here and check this modularity class here. If we come here and filter by the 0, we have all the community 0 that the software recognized. So it seems like they are mostly artists here, right? Singers. Um, let's go to the next community. I don't. I'm not really good with these names, but uh, let's see if we find the others. So it's more. There's Drake here, but it's more like sports guys. Let's see. Or this person doesn't follow anybody and nobody follows them. So in degree 0 is 0. So it's on one account, separate community just for him. And here it seems like more soccer players on this community. I know this is not perfect, but it looks like it's trying to find the soccer players here as it looks like, or people that follow more soccer players. So it kind uh, uh, try already to group these people that have more interconnection. So now let's go to the graph, and it's just put everything in the same place. So what you're going to do is try to make some this more information here, right? Um, so let's come here and organized by Modularity class. And so here are the 7 communities that it identified, and the two accounts that don't follow anybody, they are 4 and 6. So it's actually these 5 communities that the software thinks that are more related. So let's apply this palette. We can change here. Let's put this one and apply. This doesn't make sense yet, but just let's go to change the size. And for now, let's use in degree and make it from 1 to 20. Let's apply. It will not show here because it's very concentrated here. So now let's try to run a layout. The best one for this kind of thing, as I understood, is this force 2. Let's put the scaling for 200. Let's add this and prevent overlap. All this helps to spread and make more clear the graph. So let's run this. So as you can see, it starts to spread the nodes. And as we already put color on the communities, you can see that here there's a community, here seems that there is a community, here another one. It takes a long time. So I will accelerate this process so we don't need to wait. So after the software run this layout, we reach this graph here, and let's do some analysis on it. Let's separate the communities. So we can come here and add this modularity class node, so we can separate among the classes. So let's see. So here it's showing only this class. So it seems like it's a lot of artists and singers here. So let's analyze this one. This is the soccer players. Cristiano Ronaldo is here. Neymar, Marcelo, Sergio Ramos, Messi, Mbappe. Let's see here. This is a football media account that's very large, 433. Georgina Rodriguez is the wife of Cristiano, and see, as she's an influencer, she's near Dior. So the software thought that. So it identified very, very nicely the community. Here it seems like they connect Snoop Dogg and Will Smith, and some more class here. I don't know why it is classified like this. This one, and a very small class just with card B. So I believe we did a good work here, and just one more thing, that we can do an export here. If we come here, we put the show labels and then refresh here, it generates a nice graph so we can export it. We come here and we can export the graph as PDF or as SVG or PNG. So then we also can come here again and just print the community we want to, like this, and come here again, refresh, and we can print the separate community here. So this is what I did for this video. I hope you enjoyed, and if you have any questions or see if I did any mistake here, please comment on the comments area. And that's it for today. Thank you.